Let's state and prove some theorems involving linear independence. In particular, we'll show that vectors are linearly dependent if at least one of the vectors is a linear combination of the others. We'll start with the special case where we have two vectors. A set of two non-zero vectors is linearly dependent if and only if one of them is a constant multiple of the other. Let's prove this. And because it's an if and only if statement, the proof will have to go two ways. We'll start with supposing that we have two dependent vectors. And we want to show that one of them is a constant multiple of the other. Well, by the definition of dependence, there are numbers C1 and C2, at least one of which is non-zero, such that this combination equals the zero vector. Let me see. At least one of these has to not be zero, so it doesn't matter which one. Without loss of generality, suppose it's a C1 that isn't to zero. Then you can do a little algebra and find that V1, I mean, just taking V2 over here and dividing, V1 is a constant multiple of V2 as requested, as desired. Now let's go the other way. Suppose that one of these vectors is a constant multiple of the other. Say V1 is K times V2. Then 1 V1 plus negative K V2 equals 0. 1 is not to 0, so this is definitely a non-trivial linear combination, whatever K is, and V1 and V2 are linearly dependent.